Welcome back to Ox Tools. I'm Tom. So we got a big batch of meatloaf here for you guys. This is right before the 2017 Bar Z Summer Bash. So if you don't know about that, that's an event in Southern California where a bunch of YouTube creators get together and we meet a bunch of viewers, we have some contests and do some demonstrations and have clinics. It's a lot of fun and I'm looking forward to it and taking a little bit of vacation. And we got our Keith Fenner A-Bomb 79 rematch, 4-jaw rematch down there, so that ought to be pretty interesting. But meanwhile, we got some cool tools. I won a couple of local auctions, online auctions, so we're going to look at some tools that came from that. I got a tool that we're going to send off to another YouTube creator and equip him with something he doesn't have, and some viewer mail and some books, all kinds of stuff. So it's the typical meatloaf, and let's get going. All right, so here's our first item on this nice meatloaf here. This comes to us from Neil Zimmerman in Benton City, Washington, and he wanted to send something into the show, and he sent in this German copper hammer, which is pretty cool. And it's kind of unique in that they haven't done a lot of finishing work on the head. I guess they figure you know, a copper head like this, you're just gonna mushroom the heck out of it anyway. So they didn't spend a lot of time messing around with that. But it's a sturdy little bugger, I can tell you that. And I haven't taken that off to see about replacing the head. Or the handle, vice versa. So anyway, Neil decided to send something in, and it's called Der Hammer as opposed to the hammer. So, or that is the hammer. So anyway, kind of a neat hammer, and it's I don't know what do I want to say about it. It's not super streamlined, but it has this kind of rugged. You know, stocky build about it, so which is kind of appealing, so kind of neat. 1,000 grams and a nice soft copper. So copper is actually really good, better than brass in my opinion. It doesn't skid off of things, and it marks less than brass does. Brass is actually kind of hard sometimes for whapping on things. So anyway, Neil, thank you very much for sending that in. That's pretty cool stuff. All right, this next one here, this comes to us all the way from the UK, East Sussex to be exact, and this is from James Parker. And these are some kind of wartime training manuals here, which are kind of neat. And these particular ones are about metrology and different kinds of measuring. So he thought I would enjoy these, and he was absolutely correct. So what do we got here? Manual, okay, measuring with light waves. Testing surfaces by the inclination method. And what else we got? Testing rectangular steel straight edges. Very, very cool stuff. So these are the kinds of straight edges that you use on surface plates and things like that. Not these super hyper precision ones, but these are just kind of generally utility straight edges here. So kind of neat. And it tells about the you know, we've talked about this in the past, these airy points here to support the, or bezel points actually, so to support the straight edge so that this edge stays as straight as it can being supported. So the danger is if you support it on the surface plate, it mimics the surface plate. So this is a better way to test it. So anyway, James, thank you very much for sending these in all the way from the UK. That was very nice of you, and I really appreciate it. And we'll peruse these and see if there's some really video-worthy stuff that we can find in here. Thank you, sir. So you never know who you're going to meet on the internet. I did some. Those of you guys that follow me on Instagram, you know, I've been putting some pictures up of some of the things that I've been lapping, just kind of offline as part of my learning and experimenting process. Anyway, I put a picture of, these are some carbide face seals. This is a used one, and this is one that I relapped here. And these guys actually follow my Instagram channel, which was kind of surprising. And this is a real company here, you know, a real big company. So anyway, Lapmaster Wolters, they make lapping machines and lapping plates and consumables and stuff like that. Anyway, I got to talking to them, and they sent me a little swag bag. So I'd like to show you some of the stuff. You know, it's the usual trade show stuff. There was some pens, and there's this little guy here. Oh, it's a little tape measure. Okay, no comment, I guess. Anyway, it's got their little logo on it and stuff like that. And then they sent me a couple of hats, which is really cool, right? And well, they asked me what I wanted, and I actually wanted one of their posters. They have a really neat paperweight. They have a really neat poster, which I'll show you in just a sec. And I said, hey, you know, could you send me one of those posters? And they did, and it was really nice. So Lapmaster, if you're looking for lapping supplies, check out their website. They sell all kinds of stuff, from huge machines down to little hand lapping kits, and with all the supplies that you'll need to do that. So I have some of their gear. I have a monochromatic light and a couple of optical flats made by them. So anyway, let's check out the poster because it's kind of neat. This is the poster that I wanted here, and this is like, it's printed on this really heavy. It's almost like vinyl, like a sign, right? Anyway, it's pretty neat because this shows the different kinds of geometry that you can inspect with optical flats, right? So it's showing, you know, a different kind of surface and how that might show up looking at the interference bands. And at some point, I'm going to do a video on using optical flats and how they actually work to produce these interference bands that you see that we can interpret as surface geometry, which is kind of neat. Anyway, Lapmaster sent me this, and this is pretty cool. It's hanging in the shop now, and then it'll show up in another video when we talk about optical flats and measuring flatness with monochromatic light. It's really kind of a neat subject. All right, so here's a big pile of cool stuff. Some of this is this auction wins that I had. This was a kind of a public auction that was online, and I bid on a couple items, and lo and behold, I won. I put some little cheesy bids on some stuff, and I guess nobody else wanted them, or they weren't trying very hard, let's put it that way. Let's take a look at this guy right here. This is pretty neat. This is a Pratt and Whitney Electrolimit gauge, which is basically a comparison stand. And really what I wanted it for was the stand. The stand is really, it's a husky, sturdy stand. This is kind of antiquated electronics here, although it still works, and we're going to show that in a little bit. This reads 1 division is 50 millionths of an inch. So the important parts of this are the stand and the anvil, okay? That the stand is thermally stable and rigid enough that you don't get measurement noise when you're doing lots of measurements. So and the anvil needs to be really flat and really smooth, which this one is. In fact, this is a gauge block. The gauge block, it still rings to the platen, even though it's serrated. So and the serrations are just so dirt has a place to go. When you slide stuff around, dirt tends to collect in the grooves and not between your sample and the measuring surface. Now this it was missing this little sheet metal cover here, and we'll zoom in on that and take a look at that because that's kind of neat. And the cord's pretty crunchy, but I'm going to strip the electronics off of this and put a modern gaging head on here in the future here. But let's look at this a little closer from a kind of a design standpoint. And here you can see a little bit closer here. You can probably just see these little solenoid coils in here. There's one at the top and one at the bottom. And as this arm moves up and down, you get a differential voltage between those that they translate into, a meter reading, which pretty cool. And so let's loosen that up. And then when I turn the crank, I can move this up and down to make a coarse adjustment. And it's just smooth as silk. So everything's aligned really well. This cylinder appears to be chrome plated to me. It looks like it's chrome plated and ground, and it fits this cast iron housing here. They've lapped it or honed this to fit in a really, really sweet way because it just operates very, very nicely here. Acme screw to raise and lower it, and then we'll take a look at the. I'll turn it around. We'll look at the locking mechanism because it's noteworthy on a way to lock against a round shaft like this without marring the shaft. So people struggle with that kind of a thing. So let's take a look at that. Let's take a look at this lock here. So it's got two separate pieces here, and if anybody out there has actually taken apart a Bridgeport quill locking mechanism, this is very, very similar to that. So if we're lucky, we'll be able to get it apart. So I don't know if I'll make it. Oh, I can get it out. Okay, great. So you see what we have here? So it's got a scallop cut out of it. And actually, I think that far one was in there backwards. So it's got a scallop cut out of it. One has a clearance hole, and another has a threaded hole. And what happens is it pulls this together inside a bore and clamps against that. So you get a nice clamping mechanism without putting a kind of a point pressure like you would get with a set screw. So yeah, I think that was in there backwards. Let's put it back in there and see if it should only, and it also, the beauty of this is because this is cut away, right? And see, they finished that even better there. Because it's cut away, it's an anti-rotation feature, so you get, I would call it bonus action there from that. So let's thread that in. Let's see. Okay. Yep. So it doesn't take much pressure to lock it, and then it unlocks quite easily. So no need for a spring in there. It's fitted so well that any reduction in the pressure just frees it right up. So anyway, that's that lock. All right, let's plug this thing in. It's got this really crunchy cord, man. This would not pass electrical safety check here. Just waiting to get zapped. All right. So we're gonna try this thing out here, and you can see that this meter is actually reading a very, very low voltage here. So let's a very small voltage, I should say, not a low. Yeah, it's low voltage, right? All right. We'll come down on the gauge block here. And this has I noticed I was fiddling around with it, and it has a sapphire tip on it, which is kind of interesting. Okay, so I'll get it close mechanically, and I'll lock I did pretty good. And then it has a 0 rheostat over here. This thing's a little twitchy. I guess I would be too if I was, 70 years old or whatever. So that's the idea. Now, actually, what I should do is I should see if it's actually measuring correctly. I'll get a couple of gauge blocks that are 1/10,000ths different, and then we can try it and see if it's actually measuring properly. Oh, let's look at the voltage here. So I don't know, 6/1000ths of a volt. Yeah, 6 millivolts. Pretty small. So this, no, it's calibrated so that it's 0 voltage when it's at 0, and then it's proportional to the distance, I guess, is how it works. And there's, I don't know, there's a converter, or what would it be? So it's AC to a transformer. I'm pretty sure these are DC coils here. Yeah, and you can see this is dinking around a little bit. Let's measure something. Let's see here. Put it on the smaller one first. This is. Let's see here. Let's go that way a little bit. Zero up on that. And then we'll put the other one on. And it doesn't read right. These aren't ringing together properly. These thin gauge blocks sometimes. This is an old set here. Let's see, can I go all the way down on the platen? Let's try that. If I can go that low. Should be able to go that low. And now we're getting more range out of it. What's going on there? All right. 0 up. Let's try that one. Yeah, well, it doesn't read right. So these are 1/10,000th of an inch difference. So I should have got a full division out of it, a full large division out of it. These are 50 millionths per little tick. So anyway, it doesn't read right. It sort of works, but yeah, look, it's going all over the place. This next one's kind of neat. This is another lot that I won from that same public auction. So these came from a local community college. So I guess they're cleaning out a metrology lab or a science lab or something like that over there. So they're getting a few interesting items. These kind of popped up, and they're granite sine bars is what they are. And you just don't see this kind of stuff that often. There's no maker marks on these, but I'm pretty sure that these were made by the Doall company. Doall did a lot of I wouldn't call it experimentation, but they kind of reached out into the metrology world with granite stuff. So they make a lot of granite products, and so there's all kinds of examples of Doall granite, weird articles. Anyway, this I think is a couple of those. It looks like they're dated 1971. Is the vintage of these, and they're pretty good sized. Kind of too big to use on a machine, so it's really kind of a metrology setting that you'd use these. This one, I believe, is probably the more useful one here because it's it's got a decent work surface on it, and you can set some stuff up. Although this one, it's a big bugger. Now it has a weird center distance on the rolls. Let me get my tape measure here and see. I measured it and I went, what? What kind of wacky number is that? It's like 21 5/8. So, yeah, I don't know if it came with a calibration number or something like that. They just you know, ground it, and whatever it came out, they just gave you that number, and then you just calculate the sine based on that number, right? Let's see if this one's an oddball here. Yeah, this one's 10-inch here, so you know, a little more normal here, but this one's kind of an oddball here, so yeah, it's a freak. I measured that and I went, what kind of goofy stuff is that? So there's a couple little angle plates. I'll show you those too. All right, so here's the angle plates, and this is really what I wanted out of this lot. Unfortunately, it's got a little chip right there. Not too bad though. So these are insert angle plates here. So they have some threaded holes, and then they also have a steel disc, so you can suck these down to a magnet on a couple of sides here. Once again, not in the best shape, but I'll check them for squareness and see how they are. And you know, they're certainly usable, but we'll see how accurate they are. Anyway, this whole lot was $43, so you kind of, I threw a, I don't know, $50 bid on it and just forgot about it, and they said, oh, bing, you won. And I was like, oh crap, okay, so now I got to go get it. So I drove all the way out there and got that, but I also got the Electrolimit as well. So anyway, granite products from Doall. All right, this next lot of interesting tools, this comes to us from Sweden, all the way from Sweden. This is Robert Fernstrom, and he emailed me and said he had a pile of, he was cleaning out some stuff, and he had some things he thought I could use. So a big, I don't know, big crate showed up, well packed and strapped, and this is the stuff that was in it. So pretty neat. There's some real interesting articles in here, and let's take a look at some of the special ones. Most of these micrometers here, boom, 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 bing, bing, bing. These are Johansing, CE Johansing micrometers, which if you guys know your gauge block history, this is Carl Johansing that made the first gauge blocks in Sweden, and he used a converted sewing machine and made it into a lap and worked out how to lap these things consistently to make the first gauge block sets. And he later on partnered up with Henry Ford, which is kind of neat. So the company has a long history. Now he really aggressively protected the secret of how he measured them and how he made the blocks, which was I always like that when guys are able to keep processes secret like that for a while. So it's kind of neat. Anyway, some of these I've cleaned up already. I've given them a spa treatment in the ultrasonic and an oiling. Some of them I haven't done yet. So. And then there's some Mitutoyo stuff in here too. This is a V-anvil micrometer. This is for measuring things with odd numbers of flutes, 3, 5, 7 flute type things. They're a little tricky to use, but it's kind of the only way you can measure that stuff unless you have a way to accurately rotate the tool. This oddball thing, I'm calling this the Jimmy Page micrometer here. It's like one of his double neck guitars, right? This is a tolerance micrometer here. So what you would do is it would be set up kind of like a go no go situation, and then you can check parts. So you can set a very small difference between these two and check a part. So I don't think this thing's ever been used. It looks flawless. So. Yeah, anyway, pretty cool. So there's that. A couple of Morse taper sleeves. This is a offshore micrometer here. This is just a 25 to 50 millimeter Mitutoyo here. It looks pretty good. Carbide faces. That'll get cleaned up. And then we got a NSK inside mic. It's kind of a short range. This is still, you know, even though it's metric, these are great. And the way I use these is I just use them like a telescoping gauge and just adjust them, and then I measure over the outside with a micrometer. Because usually you're trying to match something to a bore or whatnot, and sometimes it's easier to get a 2-point measurement. So let's see what else we got. Some thread gauges, some weird threads, ring gauge, some CEJ taps, which are kind of neat. And then we have some Oberg files, and these are brand new, and they're just sweet files here. And then I guess these are some that he sent along that are made in Poland. They look pretty good too. So we'll try some of those out. You guys know how much I like the file. So Robert, thank you very much for sending all this stuff in. This is great. I'm still going through it and fiddling around with it. I'll get all this cleaned up real nice. And now, at first glance, it looks like a standard for measuring, but it's really not. You see the ends are not spherical or finished, so I think that's just a drill blank there. Let's get some mystery markings on there. I don't know. So anyway, cool stuff. Thank you very much for sending that in. I really appreciate it, and it's a really nice lot of historical tools. This next one is a eBay find. Yes, I'm always fishing around on eBay pretty much all the time, and this thing popped up, and it was listed as not working, or for parts or something like that, or maybe it was I don't remember now exactly what the text of the auction said. But what this is a gauge amplifier. So this is for electronic measuring gauges, LVDTs, and electronic test indicators, things like that. So this amplifies the gauge head signal and translates it into a measurement. Now this is kind of a nice one. This is made by Alina, which is a Swiss company, and it's called a Pretec. It's got that kind of, I don't know, what's that styling there? 70s styling there, I guess what you'd call this particular one. And anyway, like I said, it popped up on eBay. I threw kind of a chicken bid on it and just let it ride, and lo and behold, I got it. So final sale price was $29, and it was almost $20 to ship it. So, but anyway, it showed up. I played around with it a little bit, and it seems to work. Now, it took me a little while to kind of figure out all the settings on this thing, and it's got some kind of interesting modes, this particular one. So let's fire it up here. So it has two power cords, so it has this kind of like, Siamese Dawn additional thing, which gives us some other functionality that's kind of interesting. So I have a little gauge head hooked up to it right now, and yeah, we should get a signal. This is pretty cool. You get the little lights there, okay? So that's the basic measuring mode, and then you have a bunch of ranges here. And this one will actually measure 1 division is 5/millionths of an inch, that's pretty good. Not the best that you can buy, but or not the highest resolution you can buy, but plenty enough to get you into trouble. Let's just call it that. Everything at this level is pretty squishy, and this thing acts more like a thermometer than it does a measuring tool. So if you're not careful with temperature and all that, then it's anyway, it's kind of frustrating sometimes. So that's the first mode. Okay, then it has another mode here where it will take the max reading, which is kind of interesting, and I can zero it here, beep, and then what it'll do is it'll take the I gave it a little too much there. Did it again. Let's see if I can do it a little smoother. So it'll just give the max reading. So it'll give the peak reading and store it, which is kind of, it can be useful depending on what your measuring setup is. And and then you just re-zero it here. And then it'll do a minimum, and then a min minus max, and then a max plus min divided by 2. And don't ask me what you'd use that for, because I'm not sure. Now, it does have an interesting function. It's called a differential mode, okay? And we can put it in a differential mode here. And there's a little switch on the back where I can actually incorporate 2 gauge heads and do a differential measurement. And this is handy for measuring size and ignoring position. So, in fact, this is the best way to measure gauge blocks, for example. So they don't just stick a gauge block down to a platen and then measure its height. What they actually do is they stick it down to a platen, and they have a sensor underneath and they have a sensor on top. So it measures the length without respect to the position of the platen. So if the platen was up a little bit or down a little bit, you'd still get the same number, okay? So it's kind of nice when you have things that may be out of position, or maybe you just want to measure a diameter or something. So I'll set it up to show the differential mode real quick. And so basically it's one sensor plus the other sensor gives you the differential reading. So let me set that up and then we'll take a look at that. I think I got it here. Okay, so we're turned on and we have two gauge heads that are on, so I can hit that one, and then this one adds to it. Okay, so you can see that the plungers of the gauge heads can move either to and fro there, right? So what we're going to do is we're going to pass this through. Okay, and you know, you'd have these on a proper stand and they'd be set up. But now what I want you to watch is I'm going to wiggle this a little bit. Oops. And try not to move it off of the diameter. So I can wiggle this, but I'm not doing a very good job here. Sorry, guys. I think you get the idea, though. So, all right, there's the peak. And then if I wiggle this around, I'm moving this a considerable amount, but I'm not getting much of a change there. Now, if you had a proper non-rinky-dink setup like what I have here, you could really see this better. So hopefully you can kind of get the idea there. So it's diameter without respect to position. So now if I put this down on a, see the magnet's on here. If I put this down on a surface like this, right? What that means is I have to be perfectly aligned with that surface to get a true reading, and that's not the easiest thing to do. Say this thing was really long, right? And I'm trying to support it on an anvil and not have it droop and run it through a sensing head and a platen. That's a very tough thing to do. So anyway, that's kind of an example of differential gauging. So I bought this for a fellow YouTuber and that wants to get into electronic gauging, and we're collaborating on a project together, and this is an opportunity for him to try out some electronic gauging on his new tool. So anyway, you'll probably see this again soon. Well, I had a shop visitor all the way from Austria. Is that where he lives? I think he lives in Austria. This came from Sam Wagoner, and he's a viewer of the channel, and he's been watching for a while, and he actually has my book, and that's kind of where this joke came from. Sam, he has a really interesting job. He services these machines that test wafers. They electrically test wafers, and we were talking about it for a while when he was here. And so when you have wafers, you have all these components on the wafers, and there's literally thousands of electrical connections that have to get made all around this thing. So they have these little test points. So they could have 20,000 or 30,000 points that have to come down and make a connection, and then they run a test on the wafer, and maybe it has 2 or 3 that are bad or whatever, and then shoop, it sends it on to the next operation. Pretty cool stuff. So electrical engineering, metrology, precision mechanics, all kinds of really neat stuff. So anyway, Sam came out, excuse me, and we had a great time, talking around in the shop, and he brought me a little gift here, which is pretty cool. And this is related to something that's in my book. If you haven't seen that, then you can go look in the book. What he did was he made a bunch of stamps with his laser cutter or engraver, and these are what I call ANSI wiseguy symbols. So the story is part of what I do during my day job is I review mechanical designs and I comment on manufacturability and feasibility and things like that. So so we balance manufacturability with the physics and the science that needs to happen too. So sometimes those are in direct conflict with one another, as some of you well know. Usually a lot of what I do is I flag features that are a problem from a manufacturing standpoint, and may or may not have to have those particular geometries. So anyway, sometimes I mark little joke symbols on the drawings if it's a designer that I work with. Oh, that's right, the rubber. Oh, okay. So this is the legend on this side, and then it's the rubber stamp on the other. I forgot there was rubber on there. Yeah. Anyway, some of these are, this is regardless of feature size. That's an expensive feature. That's a really expensive feature. Night shift screwed up. That's a deadly feature. I forgot what this one is. Anyway, they're in the book. And hammer to fit, tight, really tight, radius too big or radius too small, and missing dimension. I can't remember. Just make it. Just make it. Okay. Anyway, so Sam, thank you very much for dropping those off, and I had a good time talking with you. And Sam lives very close to Stefan and Gottswinger he's in Germany. Yeah, so he must be in Germany. So not in Austria. I don't know what I was thinking. Maybe he came from Austria or he works in Austria. I'm not sure. Anyway. He dropped off some goodies, and hopefully we can get a little collaboration going between the three of us. So, Sam, thank you very much. That's a fun gift. This next one is from a gentleman named Asher Peltz, and he is from New Jersey. And he bought a lot of machinist tools, and I guess there was some pretty good stuff in there: Brown and Sharp, Square, Etalon, Micrometer, and a few other things. Anyway, there was a couple items that he didn't really have any use for, and he thought that I might like them, and he's right, I do like them. So he sent these into the show, which is really nice. So Asher, thank you very much. What we have here is this is a magnetic transfer block, and it's basically brass with a lot of holes drilled in it and steel pins inserted. And the idea is that you use this to on the magnetic chuck to support parts, but actually bring the magnetic flux lines up through the pins into a part that's sitting on top. It wouldn't be something like this, but if you had a block or something that you wanted to put on there, or something that needed supported in a different way. Anyway, it needs to be cleaned up a little bit, but it looks like it's in great shape, and we'll just clean it up a little bit. And I have a couple that are similar to this, but not one quite like this. And then there was a little reamer, and I forgot to look at the size here. I can barely read it here. So 1285, is that right? 1285, something like that. 1285. It looks a little bit chowdered up, so I don't think this is gonna isn't gonna survive past this filming. But the thought is great, Asher. I appreciate that. And then here's a little relieved end mill, and this is pretty common to see double-ended end mills like this with one end completely blasted off. So they probably relieved both ends and then lost one end and finished the job with the second end. But this is a pretty common operation. This is a great job for a surface grinder and a little spinner. You can relieve the shanks behind here and reach down into things that you didn't know that you needed to reach down into. Anyway, Asher, thank you very much. Appreciate you sending that into the show, and best of luck on your flea market findings. So what we got here, this is something I showed on Instagram the other day. And what it is it's an extension of the mini pallet system. And what it is it's a small angle block with a dense pattern of 1032 holes in it, and then a couple of holes that are tapped in line with one another. And the way we use this particular little monkey here is, let me kind of demonstrate. So a guy that I've been talking to online, actually a fair amount, he's recovering from some cancer therapy, And so he's kind of stuck at home and recovering, so he and I talk back and forth on email. And his name's Mark Nelson. And Mark, how you doing? He suggested, and actually it's a really good suggestion, doing a series of videos on compound angles. And a quick search shows that there's really not a lot of information about compound angles. And it's something that if you don't do it all the time, which I don't, it just comes up every once in a while, you got to kind of relearn it every time you get into it. Now, the most common application that most people run into is grinding tool bits. If you want to do really sweet tool bits, the surface grinder works really good for that. But you got to understand compound angles, and you got to have a couple little tools that help you set them up. And this is one. So this is a Acme threading bit here, and so this might be a common thing that we would want to grind, right? So as you can see, we can easily clamp a tool bit to this to work on a particular surface. Lots of ways to set the angle. We'll get into that when we talk about the video, but here's just the dog simple way that you can set the angle. If you have good perpendicularity on all your sides, excuse me, you can just you know, and depending on the accuracy level that you want, this is fine most of the time for tool bits. Okay. Then so once we get it all clamped in place, what we can do is we add our I don't know, I guess I call them the pivot studs here, and these are shoulder bolts that have had the heads removed. Let me just pop those in there, and now what we get. Actually, you know what? I should probably put it in this way so you guys can see it. Let me get it in there. Everything's all fussy here. All right, and then we'll just give this a little snug. Now, we're sitting on the pins, so they behave like a parallel, but it allows us to tip this and put the relief angle in, okay? And so you can stuff an angle block under here, depending on what your relief angle is, or if you have one of these cool modified Adam Booth specials here. I saw this on Adam's channel, and I went, why the hell didn't I do that years ago? You know, like everybody's probably got a couple of these, right? So I just lopped one off, and it's great for measuring tool bit angles and things that are tricky to get access to. So then we set our relief angle like so, and we lock her down. And then we can go over to the surface grinder. Bzz, 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 bzz. That's surface grinder noise for those folks that don't know what that is. And then when we want to do the other side, well, you can flip it over and kind of rinse and repeat. Or if you got a bunch of them to do, what you can do is you can set up a little fence so the angle stays the same. And then we just flip it over, and then you change the relief angle to the other side, and Bob's your uncle. So off you go. So it's kind of a simple way to do that, and here's a couple examples of things that are pretty easy to grind with this kind of a setup here. So a grooving or parting blade of a particular width with particular relief angles. You're similar to that, okay? And then here's one that I was fooling around with for. Let's see, do I have the other example? No, I don't have it here. For slotting, right? So say you wanted to kind of like a Bridgeport slotter that works in this direction here. But you know, you can make a hand tool bit that you can use in the lathe to broach keyways, and you just broach them a thou at a time, zoop, 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 like that. Probably going to need a little more end relief than that. And these are just plastic analogs here, just so that they're quick and easy to cut, and you can kind of do it in the mill to kind of get your moves down. So anyway, I'm planning a video on compound angles and setups, so stay tuned for that. Anyway, here's a mini angle to go with the mini pallet system.